Today we're on chapter 12, section 7, rational expressions with unlike denominators. In other words, when the bottom numbers don't match. This is when the chapter gets a little bit harder. You're going to have to stay with me. On a normal fraction, you know that the bottom numbers have to match up for you to add the top numbers. So you would go through the process of going 6 and 4 go into what number? Oh, they both go into 12. So how do I take the 6 and make it into 12? I multiply it by 2. What I do to the bottom, I have to do the top. So 5 6 becomes 10 twelfths. Over here, 4 times what is equal to 12? 4 times 3. So 3 times 3 is 9. So the answer here is 19 over 12. You don't add the bottom numbers. Or 1 and 7 twelfths. Well, you're going to do a similar thing when it comes to adding rational expressions. But first we're going to work on how to find that least common multiple, okay? The number that both the bottom numbers will go into. And of course we're going to do that with rational expressions or things that have x's in them. So if I had done the problem before, I could, to find the number that they both go into, write all the bottom row of the factor tree. So 2 times 3 and 2 times 2. And what I'm going to do is I'm going to circle a pair, and I'm going to put it down here, and then I'm going to include everything else that they have. So it's one representative from a pair, and then everything else that they have, which gives you a 12, not a 14. All right, so let's do a similar thing with terms that have variables in it. Let's say I want to find the smallest number that both of those can go into. In other words, I want to find the least common multiple. Well, what I'm going to do is I'm going to write out what would be the bottom row of the factor tree. Now, you're going to end up not doing it this way. I have a funny feeling, but this is 3 times 5 times m times m times b times b times b. And this is going to be 2 times 3 times 3 times m times b times b. So I circle what they have in common. Bring down that representative. Then I multiply everything else. 2, 5, 3, and then I've got one representative there, so it's an M and a B. But then I have another M, I have another B, oops, there's another thing. So, and a B. So when I multiply that all together, I'm going to end up getting 90 m squared b cubed. Okay, and that is the least common multiple, or the number that they would both go into. There's probably a shorter way to do this, which is the way that I think that you're going to end up doing it. The numbers, I would look to see what's the smallest number that both 15 and 18 can go into. And you might want to do just the numbers with the bottom row of the factor tree and do it that way, but we quickly find out that it's 90. Then I look and I go, what's the highest power of m that I have? M squared. What's the highest power of b that I have? It would be b cubed. And that right there is your least common multiple. All right, let's do another one. Let's say I have 12 b to the 4th, c to the 5th, and I have 32 b c squared. The highest power of the number, and that's going to make it a little bit more difficult, but like I said, on the number, you might want to write out the bottom row. So it's 3 times 2 times 2, and on 32, it's actually 2 times 2 times 2 times 2 times 2. So I circle the pairs that I have. So I have a 2 times a 2, that comes from those pairs. times a 3 times each one of those, so that's 2 to the third power. When I multiply that all out, I find out that the number that both 12 and 32 can go into is 94. So least common multiple, or the number that would go on the bottom of the fractions if I was trying to find a common denominator, would not be 94. The highest power of b is b to the fourth. The highest power of c is c to the fifth. And that is your least common multiple, or the number that both that and that can be divided into. All right, let's do, these are all monomials, so let's do something that's more than a monomial. Let's say I've got these two polynomials. There's one, and here's the other one. And I want to know what the common denominator would be if these two were on the bottom of the fraction. In other words, I want to find the least common multiple of these two. What I'm going to do is I'm going to factor first. So I have an x plus 5 and an x plus 3. I have an x plus 3 and an x minus 2. That's what those two factor into. All right, to find the least common multiple between these two, now follow what I'm saying. I'm going to find what they have in common. They both have an x plus 3. So I'm going to bring the x plus 3 down, and then I'm going to lightly mark it out because I'm going to need to be able to see it later. Then I bring down everything that isn't marked out. So x plus 5 and x minus 2. That right there is the least common multiple, or if these were on the bottom of the fraction, this would be the common denominator. All right, let's do some that we actually turn into fractions here. Let's say I have an a plus 1 over a plus a minus 3 over 3a. All right, now on the bottom I have monomials. So what I do is I look and I go, okay, what number can both, there's an understood 1 and 3 go into? 3. They both go into 3. What can a and a both go into? They go into a. If I had written it out, that would be the bottom row of the factor tree. And that would be the bottom row of the factor tree. I circle what they have in common, bring a representative down, and then multiply it by anything else. So my common denominator is 3a. So then I go back and I go, okay, how can I make this a look like 3a? Well, it's missing a 3. So I multiply the bottom and the top by 3. So I have to do distributive property here. So I have 3a plus 3. And over here, this is not missing anything. So if you want to multiply it by anything, you're multiplying it by 1. So then I continue a minus 3. When I combine this, positive 3 minus negative 3 equals 0. So my final answer here is 3a plus a, or 4a over 3. But that can be reduced down. The a over a is equal to 1, so I'm left with 4 over 3 as my answer to this addition problem. Let's do another one. Actually, you try this one. This one's similar to the one we just did. So once you write it down, pause the video, do it, and come back to it. All right, do this problem out, pause the video, and come back. All right, my common denominator, or my least common multiple here, would be 5z. It's what they have in common, plus whatever else they have. So you have 5z. This one, I don't need to change at all, so I continue to bring down the z plus 2. This one, I would need to multiply by 5. What I do to the bottom, I do to the top. So that's how I take the z and make it into 5z as I multiply. Got to do distributive property here, so it's 5z minus 30. So when I combine like unlike terms, I get z plus 5z, which is 6z, and I get 2 minus 30, which is minus 28 over 5z. Now, please remember, you cannot reduce that down like that, okay? The only thing you can do is factor out a 2 on the top, so I have 3z minus 14 over 5z. You can't take that z out. You'd have to cross out that whole thing, and I don't have a 3z minus 14 on the bottom. So that's your final answer right there. Now, if you could reduce the 2 over 5, you would need to do so, but you cannot. All right, let's go a little bit bigger. All right, first thing I have to do here, now remember, I cannot reduce, I cannot separate this thing. The only thing I can do is I can factor it. So I have a y minus 2 on the top. On the bottom, I have a y plus 2 and a y plus 2. Over here, I have a y minus 2 over a y plus 2. Now, if you remember right, the way to find a common denominator, or the least common multiple on this, is I look to see what they have in common. They have a y plus 2 in common. Okay, I lightly mark it out. I can't mark out this one because I've already used this one to pair up with that. I can't pair that up with both of them. So what else they have in common is not what else they have in common, but once I pulled what they have in common out, what else I have is a y plus 2. I don't have anything else over here. So then I come over here and I go, what is missing from here to here? Nothing. So if I will, I multiply it by 1 or I bring it straight down. But over here what's missing is another y plus 2. So I multiply the top and the bottom by a y plus 2. This then would be FOIL on the top, or actually if you'll notice those are conjugates of each other. So it would be Florida. So I have y squared minus 4. So I work this out, y squared plus y minus 6 over y plus 2 times y plus 2. I have a funny feeling I'm running out of space on the bottom, so I'm going to bring this back up here. Okay, I can factor. So I have a y plus 3 over a y, or times a y plus 2, and that's what gives me that. On the bottom, I have a y plus 2 times a y plus 2. One of those y plus 2's cancel out, giving me a y plus 3 over a y plus 2. Actually, I think that would have been, I did that wrong. This would have to be minus, so they don't cancel out. So on the top, you have left that, and on the bottom, you could actually just put a squared on that because you have 2 of them. All right, now you try one. So write it down, do it, and then pause the video and then come back. All right, first thing you got to do is factor the bottom. So I have an x minus 3 and an x minus 3. Then I look to see what they have in common. They have an x minus 3 in common. So I mark out one of those from each. I'm left with another one, so I have to come down, bring it down here. Then I look, what is this bottom number missing? Nothing. So x plus 1, or x plus 7 stays right there. If you think about it, you're multiplying it by 1, if that helps you do it easier. Okay, this one is missing an x minus 3 to make it match up to this. So x minus 3. These are conjugates, so it's going to give me an x squared minus 9. So I have x squared plus x minus 2 over x minus 3 and x minus 3. You could write that x minus 3 squared if you want. I can factor that, so I have x plus 2 and x minus 1 over x plus or minus 3 squared. And that's all you can do to it because you can't reduce it down at all. All right, now we're going to try subtraction. Now subtraction has a little trick to it because the subtraction has to be distributed to all of the second terms. So look at this, you have 4 over 3a minus 6 minus a over a plus 2. All right, again, I'm going to factor whatever I can factor. So I'm going to factor out the 3, so it's a minus 2. And then I have a minus the a over a plus 2. The easiest way to do a subtraction is to go ahead and distribute. So I'm going to add the opposite. I'm going to distribute that negative or go ahead and add the opposite to what is behind it. Now, I just have a single term behind it, so that single term has the opposite value. I don't distribute the negative to the bottom. So I find the common denominator here. They have nothing in common. So I have to bring down everything I have up here. So a minus 2 and a plus 2. So what this one is missing is the a plus 2. What I do to the bottom, I do to the top. What this one is missing is a 3a, not a 3a, but a 3 and then an a times 2. A 3 and then an a minus 2, not times 2. All right, so then I go back up and I complete it. I have to do distributive property here. So I have 4a plus 8. And then I have to do distributive property here. So I have a negative 3a times that. So I have a negative 3a squared. And then I have a positive negative 3a times negative 2, positive 6a. All right, so then when I combine like terms, I have a negative 3a squared plus 10a plus 8 over the 3 times a minus 2 times a plus 2. Okay, you could try and factor that, but it actually does not factor, so you just leave it like that. All right, you try one, and then I'll give you your homework. All right, so I'm going to factor this. I can factor out the 4 right here, which leaves me with 5 plus c minus 6 over 5 minus c. Again, what I might do is I would go ahead and add the opposite, so that becomes a negative 6 right there. What I multiply it by is 5 minus c and 5 minus c here, because my common denominator is 4 times 5 plus c times 5 minus c. It's got to be a combination of everything I have up here. They have nothing in common. Over here, I'm going to multiply it by 4 and a 5 plus c. All right, when I multiply this out over here, remember I have to distribute. So I have a 5c minus a c squared, this times this and this times this. And then I have a negative 24 times 5, which is a negative 120. And I have a negative 24 times c, which is a negative 24c. When I combine like terms, I have a negative c squared minus 19c plus negative 120, and it's over 4 times 5 plus c